Now let's look at this example. How long will it take $5,000 to grow to $7,000 if it is invested at 6% compounded quarterly? Okay, so this is the compound interest. So we use this formula. A equals 1 plus P times 1 plus R divided by M to the M times T, right? So now our A is future money, which is 7,000. P is the current money, which is 5,000. R equals the 6%, so this would be the decimal would be 0.06 divided by 100, right? And M, because the compound quarterly, so M equals 4. So we want to calculate this T. Okay, so we plug in everything. So this would be 7,000 equals 5,000. 1.1 plus divided by 4. And this is the 4 times T. So now let's divide 5,000 on both sides. Okay, so this would be 7,000 divided by 5,000, so this would be 7 over 5. Or you can use the 1.4. Okay, so this would be 1.06 divided by 4, which is 1.015. So add 1, so it would be 1.015 to the 40. Right, clear. 40. So again, since this 4t, this t is in the position of the power exponent, so we have to bring down, so we use the natural log or the logarithm to the property of the logarithm to do that. So for our convenience, we always take the natural log on both sides. Not other logarithm. We like to take the natural log. Of course, you can take the common log, which is the base e, right, on both sides. So this would be natural log 7 over 5, or 1.4. So this is the power, so we can bring down in front of the natural log. So this is 4 times t times the natural log, 1.015. If you do your calculation, so t is equal to, we divide by 4 times the natural log 1.015 on both sides. So you will have natural log 7 over 5 divided by 4 times natural log 1.015. If you use a calculator, the top is 0.3364722237. Okay, keep as many decimals as possible to avoid some unnecessary errors at last. And this would be the 4 times the natural log of 1.015. You can use a calculator. It would be 4 times 0.01488811612. If you do your calculation for the denominator, right, which would be 0.05955448. If you do the division, you will have 5.64982547. If you round it to the 2 decimals, that would be 5 to 5.65 years. Okay. Okay, so the next problem is if we give it everything except the annual rate, what is the annual rate? Okay. Okay, in this example, if you deposit $10,000 in a saving account now, and what rate compounded continuously would be required for you to withdraw 12,500 at the end of 4 years? Okay, so it's compound continuously, so we use the continuous compound interest formula, A equals P times E to the RT. So now our A is given at last 12,500 and P is 10,000 and T is 4. So we plug in everything. So this would be 12500 equals 10000 times e to the 4, r times t is 4, so it's 4 times r, right? So we divide by 10,000, so you have 1.25 e to the 4 r. So since r is in the exponent, so we need to bring down, we take the natural log on both sides. So we'll bring down the power, it's 4 times r in front of natural log, so natural log of e. We know natural log of e equals 1. So it says this is the ln 1.25 equals 4 times r. So r is equal to ln 1.25 divided by 4. If you use a calculator, the top is equal to 0.223143551. Okay, then divided by 4. So this would be 0.055785888 divided by 4. So this is, sorry, this is the final, this is the divide, there is no divide by 4. This is divide this number by 4, you will get this number. All right, this is the years, the annual rate. But if the problem asks you to keep 3 decimals, so this would be 0.056. So that means which is 5.6%. Okay, so this is the annual rate.